How's it going, everybody? In this video I'm going to be walking you through a solution to LeetCode problem 1721, and it's swapping nodes in a linked list. So if we read the description real quick, you're given the head of a list, and it wants you to return the head of the list after swapping the kth valued node from the start and the end of a one indexed linked list. And by one index linked list, they just mean instead of starting at 0, they start at 1 this time. So we can look at some of the input examples for this head. We want to swap with k equals 2, which means we are going to swap 1, 2. We're going to swap this node with the second node from the back too. So 2 and 4 are going to be switched, and as you can see, they're switched here. If we go down farther, k equals 5, we'll count 1, 2, 3, 4, 5, the 7, and 1, 2, 3, 4, 5 from the back. These 7 and 8s are going to be flipped. So we can look at the resulting linked list. That is the expected solution, and we will see that instead of 7, 8, it is expecting 8 and 7. So there's a few ways to do this. If you look into the hints, they tell you that you can transform it into an array, and that should ease things up. One solution would be to add all of your values into a list or an array, and then you're going to need to map your 1 index to the 0 index, as most languages are 0 indexed arrays. Just swap those two values and then rebuild the list. This video is not going to cover that solution. I'm going to go over just doing it in place on the list, as I think that it could actually be an easier solution. One thing that was pretty interesting to me when I was completing this problem is it seemed like it was going to be a lot harder than it should have been until I started programming it, and I think the solution is really intuitive, and once you see it, you'll be able to understand it. So getting started with this, one thing that I think makes it a lot easier is just getting the overall length of the list. If you know you need to swap like the kth nodes, it will help if you know the length of the list. So I'm going to write a helper method at the bottom, and I'm going to call it getLength, and we are going to take a list node from this and return an integer. And simply all we are going to do with this is create a pointer to our head and create a size of the linked list. We'll start at 0, and then I'll just say while temp doesn't equal none, and we are going to go and iterate this. And each time we iterate it, we will increment the size. And then at the end, we can go ahead and return, call it size. We can return the size. So now at the top, if I was to do length equals self.getLength with our head, we can go ahead and print out the length of the linked list, just to double check that this is running properly. So the length of the linked list says it's 5, and we'll see 1, 2, 3, 4, 5. So this is properly returning the size of the linked list with what we need. So now that we have that, it'll make it easier to go through the list and be able to find our kth index from the beginning and the end. This length really helps us find the end index, since we kind of need to know the overall length of the list to know what the kth node from the end is going to be. So we can find that out doing we will take the minimum and the maximum for the first node and the last node index to get the position of the nodes. So I'll just say get position of nodes to swap, and I'll say something like node 1 index, and this will be the minimum of the k value, so the kth node, and then we are going to take that with our length minus k plus 1, and then we're going to do the same thing too with our node 2 index, the one from the kth position to the end, and we are going to take the maximum of k and the length minus k plus 1. So there's some adjusting for this that we're going to have to do. For example, right here, because our list is a 1 index versus a 0 indexed linked list. So moving on from that, we are going to create a pointer for both node 1 and node 2, and we're going to put them to the head. So we're going to do node 1 equals head, node 2 equals head. And all we're going to do next is we're going to loop through the list and get the pointers into position. So if you were to look at this input example right here, we want to have a pointer, we want to swap node 2 and node 4. So all we want to do is iterate this list and get one pointer sitting on this node, and then iterate the list again and get another pointer sitting on this node. And then once we have that, we can simply swap the values between these two nodes, and the process is already complete. It is a lot simpler than it seems like it should be, but it's actually not. So we are going to loop lists for position of target nodes. So we'll just run a for loop, and we're going to do a for loop in range of node 1 index minus 1, and all we're going to do is node 1 equals node 1 dot next, and then we're going to do the same thing to get our second node in position. So then we're going to do a for loop for node 2 index minus 1, and we're going to go ahead and iterate that too. So like I said once before, we are getting the position. Now that we know the length of this overall list, we are getting the position for where our two nodes need to be. So we know we need this node, this 2 node, and this 4 node. So we're iterating a pointer for this node, and then we're going to go over the list again and iterate a pointer for the number 4 node. And then once we have that, we can simply swap the values in between. So lastly, what comes up is swapping the node values. I can do some debugging real quick to make sure that we are at the correct values. So I'll go ahead and do that. So we'll say print value of node 1 and node 2, just to make sure that we are doing everything correctly. So the value of node 2 is, or node 1 is 2, and the value of node 2 is 4. So everything is running smooth so far. So all to do last is to swap the values in between. With Python, you can use kind of the swapping syntax I'm going to use. If you're using another language, you might be able to use a swap function from a standard library or something else, or you can simply just create a temporary value of whatever the type is and then swap them over. But for Python, I'm just going to do node1.val, node2.val equals node2.val, comma, node1.val. And all this is doing is putting the contents from node 1 into node 2 and the contents of node 2 into node 1. And then lastly, all we have left to do is to return the head of the linked list. Well, since we are using pointers pointing to the head, we have never even moved the head of the linked list, so we can just return the head. So this is the code. I'll go ahead and run it. And we have saved space doing this. This is constant space. This is O1 space. And this is big O of n complexity, since we are simply running a for loop through the range of the loop. We never have to do any sort of nested for loops. We don't have to allocate any memory to hold all of the contents. So this is a clean and simple solution to solve this problem. If you have any questions, feel free to drop them below. If you have any particular LeetCode questions that you are stumped on and want a solution for, drop those below in the comments. Otherwise, have a great day or great night. Thanks for stopping by.